Alright, hello everybody. 6.4, the triangle mid-segment theorem. Let's see what this looks like. So it says the mid-segment of a triangle is the segment that contains the midpoints of two sides of a triangle. Okay, so if you're looking at this diagram, the mid-segment, if you look at these two sides here, A and B, so the mid-segment here of A and B would just be point M here, which is your middle. If you look at the segment BC, the middle of that, the middle of that will be here, point P, and now that created a portion of the midsegment of the triangle, and we're going to do the same thing for line AC, find the midpoint here, point N, and then we're going to make another midsegment triangle in here. So we're finding the midsegment of each triangle, and then connecting the three midpoints, and we're making the midsegment triangle. Alright, so we're going to do a few things here in this first one. We're going to show that the midsegment of MN is parallel to JL. Alright, so there's one of the properties here. So the midsegment is parallel to JL. So MN is the midsegment, and it's going to be parallel. Well, to be parallel, we're going to find the slope. So slope of MN. So slope of MN. Alright, I have two coordinates here for MN. I could do it with the coordinates. I could use that. So coordinates of M. Here I see as -4, 3, and N, coordinates are here 0, 2, right? And you can find the slope this way. So your slope is 3 minus 2 over -4 minus 0, and you got 1 over -4, so -1/4. Right, and we could have done that also just by counting. So down 1, right 4, we could have got the slope that way. And the slope of JL here, so there's point J, and for JL, I'm just going to count this time, right, rather than using the slope formula here. So here's the slope of JL. And the slope here is, right, so I'm going to go, that's down 2, and I'm going to go to the right from here to here, and we got 1, 2, 3, 4, 5, 6, 7, 8, and right 8, and that simplifies to -1/4. So the slope of MN and the slope of JL are the same, whether you're using the slope formula or whether you just want to count them out. So they are parallel. I also want to show that MN is half of JL. Okay, so for this one, I'm going to use my distance formula here. Okay, that's one technique I use, or the Pythagorean theorem, whatever you like. So I'm going to write the coordinates of JL. So J here is -6, 1, and L here is 2, -1. Alright, and let's see what we got here. So the distance of, so we got this first distance, alright, and to remember the distance formula, it's just the square root of your x's, difference of your x's squared, plus the difference of your y squared. Alright, so when we plug this in, we got d equals, we're going to get -4 minus 0 squared plus 3 minus 2 squared. Follow this all the way through. You get -4 squared plus 1 squared. And don't forget, when you square the -4, the whole purpose for me squaring this is so it becomes positive, okay? So if you put -4 squared into your calculator without the parentheses, it's going to come up as -16. We do not want that, okay? And then plus 1, and we got equals square root of 17. Alright, and then the next one here, I'm going to do this with the Pythagorean theorem here. So remember, the D here is with, the D is really your C value in the Pythagorean theorem here. So when I found the slope, I saw the rise was -2 and the run was 8. So if I'm going to use the Pythagorean theorem on this one, again, just to keep everything fresh in your mind, so a squared plus b squared equals c squared. A is -2. B is 8, right? The original rise and run, right? -2 and 8. There's my right triangle. And C is my unknown, which is going to be the distance of JL. And if I plug this in, I get -2 squared plus 8 squared equals C squared. So 4 plus 64 equals C squared. 68 equals C squared. Square root both sides. And C is equal to the square root of 68. Now, we can simplify the square root of 68 a little further. And you definitely have seen this in Algebra 1. And perhaps you've seen this in pre-algebra as well. But you'll notice that there's two factors that go into 68 that are 4 times 17 is 68, and the square root of 4 is 2. So this is 2 times the square root of 17. So we see that when there's a square root of 17 is 1 times the square root of 17, this is 2 times the square root of 17. So JL is in fact double MN here. If you're unsure, if you literally just put square root of 68 divided by the square root of 17 into your calculator, you will see that you end up getting 2 to verify that MN is half a JL, or JL is twice the size of MN. Yeah. Alright, so you can do either way. See what else we got here. So, a little bit more about the triangle mid-segment theorem. The segment containing the midpoints of the two sides of the triangle is parallel to the third side and is half as long as the other side, which is pretty much what we just proved this here in this last picture here. Right? We show that the mid-segment is parallel and half of that third side there. Okay, so that's pretty much what we proved in that one. Alright, so here we go. So we got triangles are used to strengthen roof trusses. In the diagram, UV and VW are mid-segments of triangle RST. So let's think about that. So UV, concentrate on this one. So UV and VW are mid-segments. Okay, so that means I took the middle of RS with U, the middle of ST with V, and I drew a mid-segment. I took the middle of ST and RT and found W here and drew another mid-segment. Okay, and now I'm looking for find UV and RS. Okay, so UV and RS is what I'm looking for. Okay, the easier one is actually going to be UV here. And if you see that UV corresponds to, or is parallel to, RT, and if RT is 90, then UV is going to be equal to half of RT. So in this case, UV is going to be half of 90, which is 45 inches. Alright, and then RS. Okay, so RS, so VW here is this mid-segment of RS. Okay, so really VW is 57, so is UR, so this is also 57, right? Those two pieces are parallel and congruent or equal. So if this is 57, so then this is also 57. So then SR is just 57 plus 57, or 114 inches. Alright, and then that'll be the whole piece there. Alright, so our next example. So we have Pear Street intersects, blah, blah, blah. Your home is at point P. You can read this, blah. And finally, the question's asking is how many miles do you jog? Alright, so I'm going to figure out a couple pieces here, okay, just to because you're going to come through some pieces. So you got from point P to here, Cherry Street, is 1.3. You know Pear Street is the mid-segment here, so that means this piece here is also 1.3 from here to here. So the entire thing is 2.6. Alright, then we got some more information here. This is 2.25, which can be broken up, right? So if this is 2.25, then from here to here is half, so 1.125 from here to here. Right, and all I'm doing is just taking half of 2.25. So this one gave me the half of the half mark, 1.3. So the other half is 1.3. This one gave me the total from P to the end of the street, which was 2.25. So now I broke this down because Pear Street is the mid-segment. So just half of 2.25 is 1.125. And the bottom here is 1.4. So this is going to be, so Pear Street is going to be half of 1.4, or 0.7. Alright, so that's all the pieces, right? So all of Cherry Street is 2.6, Plum Street is 1.4, Peach Street is 2.25, and Pear Street, which is half of Plum Street, is 0.7. Half of Peach Street is half of 2.25, which is 1.25. Half of Cherry Street is 1.3 that was given to us. All of Plum Street, 1.4. Alright, so here we go. Pear Street intersects Cherry Street and Peach Street at their midpoints, okay, and that's why I was able to use these midpoints here. Your home is at point P. Alright, cool. So there's my home. You leave your home and jog down Cherry Street. You jog down Cherry Street to Plum Street. So you're going from home so you jog down Cherry Street, home to Plum. Alright, so if you travel from home to Plum, you're traveling 2.6 miles. Alright, so if you're starting from home, and I'll do this here in green. So you're starting from home, and you're jogging down to Plum Street. That brings you there. Okay. Home down to Plum Street. Check. Then you go over on Plum Street to Peach Street. So you're going from Plum to Peach. Okay, so now you're traveling from here to there. Alright, so that's 1.4. Okay, so we'll check that one off. Then you go up Peach Street to Pear Street. Okay, so you're going from Peach to Pear. So you're going from Peach to Pear. So Peach to Pear. And you're traveling 1.125. To get there. So up Peach to Pear, check. And then over Pear Street to Cherry Street. So now you're going Pear to Cherry. So Pear to Cherry. And that's 0.7. So Pear to Cherry, check. And then back home up Cherry Street. And then lastly, you're going from Cherry to home. Alright, so I'm just following along, and Cherry to home is 1.3, and is all in miles. Alright, and then it's asking about how many miles did you travel. So at the very end of this, I'm just going to add this all up and see what I get. So we got 1.3 and 7 is 2. 3, 4, 5, 6, 7.125 is what I'm coming up with. Alright, so quick confirmation here. This is 2 miles. This is 3, 4 miles. That's 6 plus 1 is 7, and 7.125. Okay, so that's how you get through that problem. Let's move on to the next one. Alright, so we're going to find the lengths. We have QN, which is the mid-segment. So if QN is 12, then PQ, all this, or PO, sorry, must equal 24. So all this is asking is, what's the missing piece? So x plus 21 equals 24. So the missing piece here is just subtract 21 from both sides, and x is equal to 3. X is equal to 3. PO is equal to 24, so it's going to be double, and x will equal to 3 in this one. Alright, let's see what the next one's going to be. This one a little more challenging. So TU and VW are the two lines that are parallel. TU is the mid-segment. So remember, TU is going to be half of VW, or VW is twice as big as TU. And you can write, and I would probably write that first. So TU is 1/2 of VW. So when you write it that way, then you say, okay, well, TU is what? TU is x plus 4. And x plus 4 has to be half of x plus 10. Half of it, VW. And whatever way you want to choose to go about this and solve, you can distribute the 1/2, or you can multiply both sides by 2 to get rid of that. So either way, so I'll distribute the 1/2 there. So x plus 4. So I'll have x plus 4 here equals to 1/2 x plus 5. Subtract 1/2 x from both sides. So 1x minus 1/2 x is 1/2 x. Subtract 4 from both sides. I got equals 1. And I'll finalize this by dividing each side by 1/2. And I get x is equal to 2. There's 2 halves and 1. So I got x is equal to 2. Once I have x is equal to 2, then I can plug back in here. So 2 plus 4 is 6. So TU is 6. And 2 plus 10 is 12. And that verifies, right? So 6 is half of 12, or 12 is twice the value of 6. Alright, so there's one more piece here. There's a construction, but I'll put this on a separate video. Alright, see you guys on the next one.